Okay, we're live.
Oh, it's
Hello,
live.
everyone. Welcome to the sixth episode of Data Pulse. My name is Jan Siekierski, and together with me is Giannis Polyzos. Sachin will not be joining us today, sadly. He had an emergency, and this is just two of us, but hopefully we'll be able to carry the conversation ourselves as well. I don't think I need to introduce Giannis to most of the viewers. He's an extremely well-recognized face in the stream processing world. But in case someone is coming from a bit different environment, Giannis is a staff architect at Verberica, one of the most important organizations in the space. And Giannis, thank you very much for coming in and for agreeing to talk to us, to me. I really appreciate this. You've been kind of you've been talking about this topic of unifying the operational analytical planes for a while, way longer than we did, and this was kind of the overall theme for the whole sequence of streams that we've planned with Sachin. So it's fantastic to have you here, and thank you. We will be talking about stream processing, and probably will get carried away a little bit. And we have a bit different format than we used to. I did provide some slides so that we have some structure, but also navigation in case anyone's watching this later on YouTube, so that you can immediately see what's here. Maybe let's start with what actually stream processing is, in case, just to set the context. And the easiest way to explain this is how does it differ from batch processing, which I guess it's been well established for a while and is very often the default.
So first of all, thanks a lot for the warm welcome here. Honestly, I'm blushing, so thank you a lot for that. The other thing I want to highlight before we start is how I love a lot of these cool graphs and visuals you have here on the data pools. I think this was the first thing that caught my eye, so this is amazing. And overall, I really like the effort you guys are doing. I think this is a really nice initiative. So, again, thank you for having me. And now, what is stream processing? So sometimes I tend to get a bit philosophical here. Like, okay, what is stream processing? For me, stream processing is literally everything around us. So if you think about it, everything that happens around the environment, all the simulations or anything, at every single point in time, if we think about it in the realm of time, is actually stimulations and events. And these events is something we always need to ingest and analyze, right? Like, for example, right now, I'm talking to you. I'm interacting. At every single point in time, at every second, something happens. I give you, let's say, food for thought. Like, you ingest everything I'm saying from your ears, for example. At that point,
just stream of information that
exactly. You process everything, and then you produce an output. This is stream processing in real life. Like, everything around us is streaming. And the way we humans reason about this is the same way we also want our systems to reason, right? Like, at every single point in time, events get generated. So within our systems, we need to generate those events, process those events, which is where stream processing comes in, and basically produce outputs. And then I will also go to what everyone says, like, okay, then you have stream processing, and it's all about real-time recommendations and things changing, and you have personalization, and you have fraud detection for detecting fraud in real time, all these kind of things. But the essence of stream processing is that. Now, when it comes to stream processing versus batch processing, right? Like, for me, if you also see my media, everything I have is everything is a stream, which goes back to the first thing I say, and I'm also a big let's say advocate of streaming first architectures, because when you think of event stream, right, batch processing basically is a subset in the sense that it's just a snapshot of what happens into a stream at a particular point in time. So for me, and when I say streaming first, I don't mean that compromise bats. Bats is there. And if we go back to the example I gave before, like when I'm talking to you, right, or you're talking to me, I'm processing everything in real time, and basically I'm producing back results. But in order to do that, the important part is that I build on my experience, right? And this is where batch processing comes into play, because you also need to account and take into account historical data, so you have more and better context, and so you're also able to provide more meaningful results. I mean, of course, there are more nuances in the place, and there is also, if you want to go into the debate of real time or versus batch processing, yeah, I mean, but this is my short definition of stream processing.
Cool. So I see the world in a very similar way. However, the argument that I think is pretty strong, that I've heard from a lot of people that are deeper in data, regarding the question, do we go into real-time processing mode, or do we stay with the existing setup? The question, the argument was, do you really need it because it's expensive? First of all, batch processing can be much more efficient for many situations. And second, stream processing and real-time processing comes with new semantics, new complexity. It's a barrier of entry, right? So the advice that I've seen in more than a few sources was that really evaluate whether you actually need it. And I have my thoughts on this argument, but I would like to hear your take on this first.
So, first of all, for the most part of my career, I was lucky enough to only be involved with streaming first systems. Now, I think the main, let's say, barrier is that stream processing can indeed be more difficult to understand. Like sometimes one example I like to bring, although might not be the best example, is that you can think of it like when you're an engineer, like a software engineer, you're writing code. If your brain and basically is really used to object-oriented programming, if you want to go to functional programming, for example, it requires some effort, right? There are huge benefits there, but it needs some effort. Now, things are not the way it was many years ago. So, for example, one thing I hear a lot is about the cost and the complexity and whether you actually need. For me, you need it in the sense that real stream processing in real time, stream processing doesn't necessarily mean low latency. And every time I hear about the cost, I'm always thinking about that one of those of the 100 posts you see every day on LinkedIn that someone ran Query X and had a huge bill on BigQuery or Snowflake or whatever. This is the first thing that comes into mind. But joke aside, for me, stream processing is about it's not just about real time, right? When you think of batch, if you put it into isolation and try to think of a batch that's running and the resources it runs with versus a long running streaming job into isolation, then there it might make sense. But if you take a step back and try and think, okay, I have bad jobs that need to run into really, let's say, large resources, right? I need to add workflow schedulers and also account for their resources to schedule the tasks. I need to make sure that schemas don't break between all the different downstream sources and sinks. And how many times have you heard of business people complaining, I can't do my job because I can't find my data and I'm waiting for data engineers to deliver the data, or they did a pipeline run, or I started this bad job and after 8 hours just blew up. Now, for me, if you take a streaming first approach there, you have a single pipeline. You can run on low. Yes, it's still run 24/7, and you might burn some more money, but you have incremental views on all your different tables. or your different tables can get updated from upstream to downstream consumers. There is schema enforcement in place, all these kind of things. This is speaking on a high level, right? Because if you try and put into context all the different variables from a business, there are many more nuances, but this is how we think about it. When someone asking for stream versus batch, yes, there are many use cases you might not require streaming, but it doesn't necessarily mean that batch is okay. And we see day to day and the importance. I think even these days with the rise of AI and ML, these systems need to go and be more real time. We see the demand daily. So, and I think there's also the good example we were discussing before, that you also see how Databricks also announced the low latency for Spark, right? Like, this is a typical example. This is one of the biggest vendors in the batch processing world. They also see the demand there. This is why there's so much investment in all these things.
Yeah. Cool, thanks. We have a question from Zbigniew Małachowski. It's a bit ahead of its time because we'll be talking about Flux and Pymon in a second. But the question is the availability date set for having Iceberg as the cold storage for Flux rather than Pymon?
Yes, basically Apache Iceberg support for Flux is coming next month along with built-in compaction service. So
Awesome.
this is all. I mean, we can touch on it later, but yeah, there are lots of benefits there.
Awesome. Yeah, we'll get to this in a second. To maybe share my take on it is that I fully agree that like latency is very critical, but the value, like this is something that Confluent was talking about for years. I think is that data value diminishes over time, and it's always better to have data quicker than later. But for the way I see this is that for many use cases that diminishing happens very slowly, right? For many use cases, if you are, let's say it's the middle of the night and people are coming to work in the morning to make decisions, if the decisions are not automated, then there is very, very little difference in value, whether this is happening in the middle of the night or in the morning. So that's how I see things. However, with the development of new tools, there are many problems with batch. One of this is this Lambda architectures where the systems for real-time processing and batch processing are separated, and you need both, but they had different characteristics. And right now I've been reading more and more about Kappa architecture, and this is what the streaming lakehouse is more or less, right?
And the other part of this is, if you look at all these reports, like business reports that go out, you will see every single one of them writes that seeing business that go real time report way more benefits. Like, I don't see anyone saying the other way around.
Yeah.
Another part now is also that these days we have technologies, probably not that popular, but that make stream and stream processing actually cheaper, like Pymon, for example, that you can stream directly on the data lakehouse. Now, yeah, there is not much, let's say, adoption yet here in Europe and the US, but it's still there. It's an option for everyone that wants. And the last thing I want to highlight, for me, it's not one versus the other. As I said in the beginning, both are required. It says that from stream and streaming first, you can go to batch. From batch going to stream, it's a bit harder.
Yeah.
But yes, there is also the tech today to do that thing.
Cool. Cool. Yeah. So I will be the structure enforcer here, hopefully, and I'll try to move this to kind of make it in preferably in 1 hour to go through all of the topics that I would like to go through. And with this kind of introduction of the problem space, very high level, we'll get into the details, I guess, over the course of the stream. Where is stream processing most valuable, and what use case categories do you see? Where is this most appreciated? Yeah, you've been working at Verberica for a while, right? And you've talked to probably tons of customers. and with Verica being like one of the largest organizations in the space, you know really well where the demand is, and hopefully we can kind of spread this knowledge today a little bit.
So business value. So business value use case. So when it comes to industries, I think the largest industries probably finance with banks and trading platforms, this kind of things. But then you also have, for example, gaming, and you have automotive, because they also invest more there now with all the electric vehicles. Like this is a really growing business, like with charging stations and electric vehicles and all these things generating data, that everything needs to be processed real time. What else? The gambling industry is another that also, gambling and betting is another one that's quite popular. But in general, I think in every industry you look into, you will find use cases for stream processing. I think the most funny one I once, this is not something I experienced myself, but I read it somewhere, was about a streaming use case for a furniture company, and this
For
is
what?
something for a furniture company, and this is something I would never have expected, or would assume that we'll use streaming and stream processing there, but they actually were using it to keep track. I think it was about some regulation stuff and around contracts and how they can view in a streaming way, and also keep track of change logs and what changes between contracts. I don't remember exactly, but I remember this was something I never expected. And what I want to say here is basically it's all around us. And then when it comes to business value, and this is also, it comes in value in lots of different, let's say, different perspectives, and different people within the company care about different things. Like the end result is business and business KPIs and business value. And this is something which is the hardest to measure. Like, how do you measure the benefits of streaming? For the most part, when companies start there, they haven't really, let's say, defined KPIs on what it means in terms of business value. They might be more like, okay, we want to start from the technical side. We want to do streaming data enrichment, and we want to use time windows to calculate user features. But then they struggle downstream, and this is where it gets a little bit tricky on the business side, because how you can actually translate these features and these technical things you're saying to more business people so they can actually understand the value. If you can tell them that, for example, this will this will reduce our churn rates by 10%, for example, or something, to actually see and understand the value, it's really, really hard. So
the way, like, one of the finance, I see this a lot. Something that I've seen in more than one case was blockchain and on-chain analysis. This is where stream processing engines are also used more than once. And everything, like fraud detection was always the first business use case that I've seen, and I've worked with something like this a while ago. But also I've seen a lot, but again, I don't have the actual data. I have like conversation with people and articles I read, right? So this functional use cases, not vertical industry, but maybe functional across different organizations, stuff like anomaly detection, customer retention, everything where time is of the essence, right? And but also there is I see the discrepancy, or maybe like this two categories. Like, one is a single product or single solution category, And another one is enterprise platform category, right? So because Kafka is very often used as the integration layer between different parts of the organization, you can build stream processing solutions on top of it. However, I haven't seen this done much, but I've read about a few situations. And the streaming lakehouse concept is, I guess, this is the proposition, right? We kind of rewrite the lakehouse in a streaming manner so that we have real-time analytical system that also, like, apart from delivering the value from being real-time, it also delivers value from solving some of the weaknesses of this batch systems. Like you've said, you don't know at what time which element of the pipeline will break. And also you have this duality of systems, and then you need to manage consistency between this, and you will not have full consistency between two systems that are being operated by different teams, right?
So basically, it's about trying to unify both, in the sense that the goal and the work we're doing with the technologies we're building is about to streams. We need to bring better analytics to data streams, because if you think about it, also with Kafka today, I mean, it's just a stream. You can't do anything really. Like, it's just an immutable log, and this is a truth. At some point, we also need to face. So we try to bring better analytics to data streams and to analytics, because until now it was more, let's say, batch oriented. Bring better data freshness. And at the same time, the lakehouse pattern is there because it allows you and brings, let's say, all these transactional properties directly on the data lakes. You can also leverage this cheap storage in a way that makes sense. And there are different approaches in the industry. Like most of the approaches these days just try to integrate Kafka with Apache Iceberg. Yeah, we have a different view on that, but Iceberg sure is there. When it comes to streaming, it basically, I was a big, and I am a big fan of Apache Pymon, only because when it comes to streaming in real time, which is basically something I'm involved with, so it's only natural. It's also my problems there. I advocated a lot about, but in the end of the day, if we can unify in a single table format and can provide both, and the use cases are good enough, I mean, I don't even know if we need all these table formats. Like, pretty much everything is the same.
Yeah. So. Yeah, I mean, and the really cool thing about Pymon is that it's compatible with Iceberg for reads, right? So I mean,
that's a big thing you raised there, because most of the time I'm seeing all these people trying to over-engineer for the upsert, so they change data capture, the schema evolution. I'm like, it's a single line command with Pymon. Just run this thing. It takes care of the schema evolution, not just with Kafka, with some proprietary solutions, but also with databases. Use that, do the ingestion, it's high throughput, it has schema evolution, and just use Apache Iceberg. Okay, you prefer to over-engineer things and reinvent the wheel. I mean, okay, but the solution is there for everyone.
So maybe since we've started moving in this direction, I'm guessing that a lot of the viewers are not familiar with Pymon. Could you give us kind of high-level introduction into what this is?
So for those of you that don't know, Apache Pymon is an open table format that was introduced by the Flink community. What it actually does different, the reason that Pymon was introduced was not to be just yet another table format, because we already had Hoodie, we had Iceberg, we had Delta Lake. The goal was to bring streaming and stream processing directly on the data lake house. So basically, for years, and as I said before, the only solution we had was Kafka and Flink, right? And this is also because of Kafka for the most part. Streaming and stream processing has been perceived as something expensive and expensive and complex. With Pymon, the goal was to bring the stream processing with Flink directly on the data lakehouse to make it more cheap and cost efficient. So basically, all the reports I have, after, for example, if you can afford actually that latency, right, because it's for near real-time latencies, typically to the minute level, if you can afford that latency, you get the solution that can be up to 80% cheaper. And you can do basically it's similar with Flux and the same. Basically, they share a lot of design principles, but the difference is that Pymon again is for low latency. You get all these things like streaming materialized views. Like you don't just do just in JSON as you would do with Iceberg. You ingest the data, but then because it also has changelogs, you can consume them and create other tables. So basically, you have streaming materialized views directly on the data lakehouse. All the changes get propagated. You have things like consumer groups directly on there. You have both append-only tables and primary key tables. Deal with upserts. You have the merge engines, which you can use out of the box to create business aggregates in the streaming way, and things that reduce the complexity of streaming of large streaming joins. You will have to do with Flink, like streaming lookup joins or partial updates, and many other things. It also has some cool features that Iceberg also has, like for example the branching. The branching functionality is really amazing because you can create different branching from your dataset, like a Git-like let's say functionality, have different branches for streams, different branches for paths, do backfilling everything. Basically, we have lots of technology there. The solutions is there. It's just about awareness for the most part.
Yeah. Like, for me, the key differentiator for both Pymon and I think Flux as well, because Flux has primary keys as well, right?
Yeah, we can touch on that later.
Yeah, so for me the key differentiator was like something that really caught my attention was that this is an open table format that has primary key support, and how it's done is that you have this changelog as ingestion, right, man table, that's kind of an in-memory buffer, but you can consume from it directly as well, as far as I understand. But then every specified period of time, let's say a minute or 3 minutes or whatever, this gets compacted, and then all of the changes gets compacted. So only like one change per primary key remains, and then this gets merged into this large LSM tree that has a primary key index. So the leaves of a tree. Oh yeah, I really hope for your corrections if I'm interested.
And this is the point you make. I just didn't want to go deep dive into the specifics. The benefit that basically Pymon brought was that it combined the log structure mesh tree, the LSM, with actually object storage. So basically, when you hear about streaming and stream processing, you think about it. In probably, I think almost every system, the log structure mesh tree, okay, with variations, obviously sits at its core because it's a data structure that was designed for streaming. Like Flink has it, RocksDB actually has it, and Pymon put it on the object storage, but ClickHouse also has it. Time Plus using it. I think all the systems that Cassandra has it, Bigtable has it. Lots of systems. So
yeah, but this is an analytical open table format, right? So this LSM lives in cloud storage, in remote storage, and it's optimized for like long-term storage and analytical use cases. And the state can grow indefinitely while still getting you primary key based behavior and really good support for retrieval by key. Yeah, so this was like, to me this is an upgrade over Iceberg. I'm still yet to understand Iceberg has introduced tracking something like primary keys, but without the query support. It's called, I think, row IDs or something like this. So you can actually append changes to a given key, but like there is no primary key like index in Iceberg as of now, right?
Yeah, but again, at the end of the day, it just boils down to use cases and what you're trying to do. And actually, all these solutions that take place, which actually scales how and what resources it requires to consume, right? Like for the most part, if your use case is only JSON, let's say from Kafka to Iceberg, then your Iceberg has a huge ecosystem. If that's only the use case, it's fine. You don't need something else. But if you want, for example, to ingest high throughput streams, deal with schema evolution. If you want to support these things updates at large scale, I will be surprised and also keep the resources low, right? Because this is also an important aspect. It remains to be seen when Iceberg with all these things how they will scale. But because I have worked with lots of people that have done R&D in these areas, I will be surprised. Again, for me, I would prefer to have a single table format for everything. I don't think we need all these table formats. But we need to talk more about problem solutions and outcomes rather than technology. Like these days, you see everyone, okay, X streams data to Iceberg. And I like this post that I don't remember who said it, but it was like, okay, Iceberg, what was the problem again?
Yeah.
And for me, Iceberg, again, it can be a great table format, but for the most part, first of all, it feels weird when I hear the terminology war and won the war of the open table formats. And the other part is that, what I want to say. I want to say something, but my brain lagged.
So maybe I'll jump in and defend Iceberg, because I think that the problem that was solving is that in the data lakes you were storing unstructured data. So like the first one was schema evolution, the other one was AC transactions. This was required for consistency, and Iceberg provided that. And time travel, these are like reading about icebergs and other open table formats as well, but Iceberg won. Probably everybody can have a different opinion on this, but I think it was most collectively sourced data tables.
Now remember what I want to say. Like Iceberg won in the sense that lots of vendors got behind it, and everyone started marketing Iceberg. So it's only natural when you try and create a hype like this and add so much resources behind it, eventually to win. But again, I don't mind about it. For me, it's about what's the problem, what's the use case, and what's the solution. Because at this point, Iceberg is definitely not an answer. At least I want to be concrete here. I'm talking in the context of streaming and stream processing, which I'm involved with. I'm not talking because there's a whole way bigger market out there, which is the bats, as we said at the beginning. That Iceberg is great. I'm talking for the specific domain with the specific problems I'm seeing daily. I want to be concrete here.
Yeah, okay. This clarifies things because that was exactly my point. That Iceberg won because of the data world, not because of stream processing.
Exactly.
Right? But in data streaming, we had this emerging standard of this stream table duality. Right? We have Kafka as the stream storage, and Iceberg as the table format that's connected to it. And we like last week we had this big announcement from Avon that introduces this into Apache Kafka. But before this year, I think we had 5 or 6 different solutions announcing more or less the same concept, which is you write to Kafka because Kafka is optimized for writes, especially writes coming from the operational plane when you write a single object, and the object is usually not a like 50 column data set. This is usually a single object that has 5, 10 columns very often. So for this, Kafka gives you very efficient writes. And then you have some sort of an engine that oversees the paired Kafka topic with an Iceberg table and manages the consistency between schemas and data, and manages moving the data to Iceberg because analytics are using Iceberg and they're happy with it, right? Mm-hmm. So this is I see huge value in this if you don't go all the way into real-time stream processing. But for real-time stream processing, you need a little bit more, and Pymon is this little bit more. Very often, what I see often is solutions like are just integrated, and going through the list of available solutions in the stream processing space. Many of them are available as single node stream processing systems that because you can do a lot with a single node. You might not be ready for an enterprise-wide deployment, but for like single product use case, this quite often would be enough, and you might just get some input, get some outputs, and not necessarily use intermediate object storage for what's in the middle, right?
Actually, the funny part, and this also goes back to the question we had at the beginning about Flux supporting Iceberg. Actually, funnily enough, this is another problem that Flux solves with Iceberg. What this means is basically compared to Kafka, and because also Flux is queryable. So basically, Flux also has by default, it also provides tiering, like from its tier storage directly on lake tables, and it started with Pymon because they also share the similar design, etc. Now Iceberg will be integrated. It's being integrated, and it's coming in the next release. So what does this mean for Iceberg users? First of all, it's not just about the JSON of the data, it's all the different layers you remember I mentioned before that you can create with Pymon, those materialized views. Basically, on the hot layer, all this goes through Flux. So basically, even if you're doing updates on your keys on your hot layer, Flux takes care of all the updates and then offloads all the data as Iceberg tables. So it solves the problem with updates for Iceberg, even if they add keys. And these keys, it can't scale well. It's not an issue because Flux takes care of the updates by nature, and then just offloads as Iceberg tables. And of course, it also minimizes the latencies because you don't have to find a way to stream and read the tables or to create workflow scheduling jobs, to schedule jobs to do the processing for you. Everything is in a streaming way. So I think these are the two main issues that it solves. And the other part is that it delivers a compaction service directly on the open source. And again, compared to Kafka, it doesn't also keep you like locked in. Sorry, locked in is not the right word. It doesn't keep you like right now. Most support Iceberg. It has Pymon. It has Iceberg. It also has Lance integration, which is also coming in the next release, which is basically a really popular. It gains lots of traction for multimodal data in AI. And if Delta Lake and Hoodie support is required, it's going to be fairly easy to add.
And just to take a step back and set the context and also
diverse a bit, yeah.
Validate my understanding, but also maybe help some viewers that are not briefly familiar with Flux that I am, is that Flux is kind of a replacement for Kafka, but it has a few unique capabilities. Not replacement, but then kind of plays a similar role, right? This is a like standalone platform that is used as stream storage, while Pymon is a table format, right? So if you are using Flink, you define that you will be persisting to Pymon, and that this is the format in which you write to S3. Is this understanding correct?
Yes, it is correct.
Okay, cool. So I hope this helps. And one of the most interesting features about Flux that I find that especially relevant in the analytical pipelines space is the ability to prune columns, because it stores data in a columnar format. So if you are working, as I said, like let's say you have an event that has 5 fields, it won't do you much, right? But if you have data set that's updated in real time, and it aggregates data from 3 different domains, and it has 50 columns, and you, for a given use case, you only want to consume 4 of them, then being able to get only these 4 columns instead of the whole object, it saves you like a ton of throughput, probably a lot of compute as well, right?
So actually, let me give a brief background also for the viewers here on Flux, because I started talking about them. Most be like, okay, what is it? What is this new thing that no one knows about, etc. So Flux is similar to Kafka in terms of it's a streaming storage, but it's a columnar streaming storage. And the way I like to talk about is basically it tries to combine 3 things. The first one is streaming. Basically, you get everything you get with Kafka, like this append only, let's say it has the append only tables, which act exactly like Kafka, the append only log. Instead of partitions, it has the concept of a bucket. Instead of topics, it has tables. And instead of partitions, it has the concept of the bucket. So basically, you get the exact same functionality with Kafka, but you get the extra benefit that it's directly queryable. So you have a log like Kafka that is queryable. The second thing is that it combines primary key tables that generate a complete change log, and it's like having a built-in cache. So for example, if your architecture relies on something like Kafka and Redis, you can replace that with Flux, because basically you have a built-in cache to create key value lookups. And the third part is basically the ability to combine data warehousing properties or lakehouse properties, let's call them, like what you mentioned, because it's columnar, like column pruning, but this goes even beyond that. Column pruning is just one aspect that minimizes the network transfer data for the required columns. The other part is supports partition pruning. So it means, like, for example, if you're interested to stream data only for the last month, for example, or something, it can only read particular partition. And the third thing is predicate push down. Like imagine like you have a stream of 10 million users, and you're only interested, for example, to create let's say a view on a particular user ID. With Kafka, you will have, of course, to consume the whole stream, transmit all the rows and all the columns with the payload, and just do a filtering then on the client side. Flux just reads the required columns, the required data from the particular user ID only, and transmits that over the network. So when it comes, it's similar to a database. You only need what you need. You only read what you need. Yeah, I'd say that.
It's as if you had like tightly integrated projection coming directly from Kafka, right? Because to get the same behavior, you would need to stream data from Kafka to some storage that and yeah. So yeah, it's built for analytical stream processing. I love to read user stories that start using this. I haven't used this myself yet.
So last week, basically it started. The early adopters started using it around the beginning of the year, end of previous year. Last week, we just published the first success story from one of those open source adopters. There will be a few more to come soon, and hopefully we'll get even more people on board. And yeah, I mean, it's an early project. This is something that when I heard about, I was so excited. I'm like, okay, this is something new, because think of it like Kafka, right? And all the single Kafka compatible API solutions that it's out there. For me, it was like pretty much everything is the same. But this, when I heard about it, like, okay, this is it. For me, I was so excited. So I got involved personally. We'll see where this goes, because as everyone knows, the best technology doesn't always make it to the market. There are so many pieces involved, which can be from simplicity to awareness to everything. So just know it's out there. We'll do our best and hope for the best. We'll see how people will. For now, there is indeed lots of interest and lots of excitement, but we'll see. We're still in the early days.
Awesome. I'm really looking forward to it. And it's under Apache Foundation umbrella right now, right?
Yeah, it was donated to the Apache Foundation officially like 1 month, 1.5 months ago.
Yeah. Okay, I see that Sachin is with us in the lobby. So Sachin, I'm adding you to stage. It's great to see you, man.
Hello, man.
Hello. Sorry, I got
Um,
a little late, but yeah, I was listening you guys on LinkedIn.
You
Yeah,
will be
it
bored.
was going great.
uh,
It was going great.
it's awesome to see you joining us after all. Yeah, so to give you a quick update, we started meddling a little bit and then get carried away into talking about Paimon and Flutes. Yeah, we're kind of in the middle of talking about the use cases. So right now I kind of I'll revert the slides to where we were, because I have one more question on this topic to you, Giannis. Then yeah, because we haven't talked about this one yet. The data stream API in Flink, right? Right now we have many different SQL engines that give you like table level semantics, and SQL like engines supporting SQL execution. But Flink is pretty unique in a way that it used to have more APIs, but right now it has the data stream API, the table API, and SQL, which is more or less table and SQL is the same, right? So we have two levels of abstraction. Where do you see this used? I mean, the data stream API. Which use cases require this more granular control, and where? Yeah, who's using it?
This is a really nice question, and basically the DSM API is used everywhere. And the funny thing is that I am also a big advocate of let's say streaming SQL, whether it's Flink SQL or whatever. Um, and then I also like to say that use SQL first, and unless required, then use the more, let's say, low-level APIs to have control and everything. Only because many use cases are pretty fine with it. The interesting part is now that even though simpler, everyone prefers to code. For almost one and a half year, I was trying to, let's say, advocate more for Flink SQL because I want people to actually understand it's easier and go with it. But I have even been to workshops that I was told that, okay, this is amazing, but this is too much SQL for us. And this is where they lost him. Like, okay, but it's simpler. Like,
Yeah.
and this is also, I think, another thing that Flink 2.0 brings on the SQL API. They actually added uh, the table value functions. Sorry, it was what was exactly the name?
The UDF. So
I always miss the
the other
name.
one, yeah.
Process table functions. Yeah, I never remember it. I always confuse that with the name with the polymorphic table value functions. Yeah, it's process table functions, which actually allows you through UDFs to have access to low-level primitives uh, like state taxes and timers. But for the most part, the data stream API, I would say, is the most highly used. And I think it's also more important these days with the race. Yes, Lorenzo, the table process functions. This is the one. It's
So what do these functions do?
so. Sorry, I just answered to a comment.
Oh yeah.
But yeah, the data stream is the most highly used API I see. It also provides lots of flexibility. And especially, I believe now with all this AI work that takes place and all the models and difference and feature engineering, I think it's going to be even though people bet a lot on streaming SQL, based on what I observed right now, I believe it's going to be even more popular. And there is lots of work in Flink 2.0 to actually they re-engineered the API because it exposed lots of, let's say, internal primitives of Flink to the end user that they didn't require to know. So the one hand Flink 2.0 aims to bring a way better user experience and simplicity, let's say, to the data stream API. On the other hand, and because it also introduces now lots of async operators and async API for state access to make it more performant, because it goes to disaggregated state pattern. It also has some async APIs within the state. So I'm really curious to see how the world approaches, in the sense that it requires to use some Java primitives for like completable features. I'm not sure if some users, I want to think that it won't change anything for most users, but because it's async now, that's my only concern. In theory, it shouldn't, but you never know.
Yeah. Honestly, what you are saying, it's a bit of a surprise, a bit of a news for me that the data stream is by far the dominant one in Flink world. And like the way I see it is that SQL brings a lot of simplicity, and I think the complexity of stream processing is kind of a barrier of entry for a lot of organizations for which this would be a benefit. To me, SQL is pretty natural because, yeah, I guess my mind works just.
No, and I completely agree. I mean, I told you, even I always more like SQL first. I think it has more to do with the way that the adoption happens, because the first, let's say, entry point in an organization typically is engineers. And let's face it, engineers love to code, right? But then when they start becoming more familiar and they try to open up the platform to more users, SQL feels more natural to them. But always the first, let's say, entry point is code.
Yeah.
And at the end of the day, if they don't code, what's the purpose of existence, right? Like when I was using for a long time SQL, at some point I'm like, I have forgotten everything. What am I doing in my life? we need coding just to keep sanity, you know. But yeah.
I'll break the general flow of the slides once again, because Sachin, I want to get your input on the Spark side, right? Because I think we each of us lives in their own bubble, right? And when I was approaching the problem of stream processing engines, I was these real-time engines, but then there is Spark, which probably moves way more volume than Flink globally. Because of how widely it is used. I don't have any data to back it up. This is just me making stuff up on the go. But, maybe you could tell us a little bit how, because there is Spark and there is Spark structured streaming, right? So how does this work in the analytical world? How widely this is adopted? So that's like two questions. Like, first of all, what the how the technology differs, or how does it look like, and the other one is how widely this is used by data engineers in the analytical plane.
Yeah. Before that, I had a point on the previous discussion that we were having.
Okay.
Being SQL as a SQL as a point of entry. The problem with that, I feel, is like, if you make SQL as a point of entry, and then you are planning to make your DBAs or someone who's like the engineers who has not too friendly with the other, like the exact ecosystem. And once you introduce to them, then they still have to know all the streaming operators definition, right? So like even if they are running the explain query on the Flink SQL, right? So they have to understand the streaming operators properly, just so that they can debug their queries and why is it running slow. So even if it's a entry point for them, but still, like, there's a lot of understanding that has to happen eventually. And because of that, once that understanding happens, and they naturally progress towards writing the code, or something like that, is what I feel. Any views on that part?
I'm curious if in the analytical world, do you see, because Spark also has it has imperative language, and it has SQL, right? And which is used. Like, do I correctly assume that SQL is by far the dominant language for writing Spark queries, or is the imperative interface present?
I can
I'm
also
not
answer
sure.
that
Yeah.
because I was using Spark for 2.5 years, in particular Spark structured streaming. I always was writing code, but also SQL code within the code. No, I don't remember the API definition as well. It was like Spark SQL within Scala code though, and mix and match of that.
Sajid, what's your experience?
I have been using both, to be honest. Mostly on the SQL part, but then like a days or two, it will hit. What am I doing with my life? And then I'll go back again with the APIs section of that part.
But honestly, I'm out of the Spark world for a long time now. But based on what I'm seeing, for the most part, it's Python code. I see more Python code in Spark rather than
Yeah,
actual SQL.
that's right. Yes.
So
But
I
that has been there, and even
yeah,
the
I
analytics teams and those teams are also moving towards more on the Python code for the Spark
yeah.
than writing SQL. But like for your ad hoc queries or for the result that you might need quickly, instantly, or for those use cases. For job related thing, I still feel Python is still there. But maybe there's something that you just want to write code quickly and just get over it. Uh, SQL is still a pretty dominant use case there as well. So we have been seeing like our analytics team uh, who has been building dashboards are now started creating ETL jobs as well using autoloader and those stuffs by the mercy of Databricks. So yeah, but yeah, see, though they were using SQL earlier a lot.
Cool. And how widely is Spark structured streaming used in analytics? Like, is this something that every data engineer just uses as part of the toolbox, or is this like is the work happening in batch mode normally, and then whenever there is a need, then stream processing is coming into play? What's your experience with data engineers?
For me, structured streaming has been working fine uh, because they are like the most cost effective throughput that they can provide uh, with like splitting stages and those stuff. So today, I think you guys are also discussing the real time mode that has been introduced by Databricks folks, right?
Yeah, Giannis
I'm
mentioned
still
it, but we haven't dived deeper into it, so maybe this is a good opportunity to.
Yeah, I'm still like I love to hear you guys like what you guys think about it. But for me, until I have a very low latency pipelines that I would need them to be, and by low latency I mean some milliseconds or even lesser than that, right? If I have that, until I have that thing, I would not be using that because of that. With the micro batch setup, right? You have the most cost-effective throughputs, and with this real-time mode, they will be doing most of the stuff in the memory while shuffling the data right away. So that will eventually cost you a lot dollars as compared to when you once you'll be doing in the micro batch. So I feel it's until the use cases requiring a very low latency type of use cases, maybe fraud detection or in that domain, or maybe something related to user centric analytics where you are exporting your analytics to your customers directly. uh, I'm not sure on the use cases where I would be using it, but really appreciate like if you guys have any viewpoint on that. And I've been using micro batch setup predominantly for mostly all of my pipelines.
I'm yet to like analyze the problem of efficiency and cost efficiency specifically. And I'm not coming from the analytical background. I'm like entering with a clean slate, I would say. So it's not the decision or whether the value is big enough to migrate. It's the decision of okay, what kind of tool sets do I want to use for this specific problem. Yeah, and I like the performance side I haven't touched yet. Maybe Giannis, you have something to comment on because okay, where I'm coming from is that Flink, like before Flink 2.0, where we have a slide about it. Before Flink 2.0, Flink was a distributed system with local state storage and local state. Right now we have disaggregated state, which allows us to have huge state in S3. So some like this made Flink much more cloud native, but also we have other solutions that were kind of trying to address the same problem. I want to analyze the performance. I want to analyze like what trade-offs are there to be made. And I've heard claims from vendors, and they sound really cool. But I'm not a very trusting person in this aspect, so I want to validate these claims before I share them. However, what I've heard sounds really amazing, and sounds like all of this is really viable, and it's possible that this massive complex pipelines will be, first of all, replaced by real-time systems, and second, just become much more cost efficient because a lot of the issues are will go away. But yeah, this is my kind of high level overview of the promises of vendors of what's coming. So I'm hopefully self-aware in this aspect. So I'm right now mostly excited about the capabilities of actually making real-time data the default, right? Because there are a few problems with, like we've talked about on data pools more than once. Giannis, you mentioned this today as well, that first of all, you need to manage consistency between different batch jobs, because you have like the whole system is fragmented into pipelines that get triggered every now and then. And second, we have Lambda and Cap architecture, so even like we need to manage consistency between two systems if we want real-time data. And it just seems simpler if we have powerful and simple tooling that allows us to build real-time system. That yeah, it just seems that it's right around the corner, and I really enjoy learning about all of that.
And to your point, what you said before, I think this is the most important aspect. Basically, as you said, you can't trust vendors because we are full of tech marketing these days. And especially like you're a consultant or I'm an architect, I never try to force, for example, going back to Spark Structured Streaming, right? I was using Spark Structured Streaming for 2.5 years. I never had issues with it. But the states at that point were also smaller, right? I don't know how it evolved right now. The only thing let's say my thought process there would be that first of all, I would like to wait for customer testimonials to see how things actually work and scale. And the second thing is about, personally, after Spark, I went into Flink and never looked back, because of the flexibility it provides, because it's an amazing engine. I like the whole, let's say, ecosystem around, like whether it's Pymon or Flux or this whole batch and streaming unification work that takes place. So because it's also about the community. But the important part, when you talk with customers, every single time, I always go and say, run a POC. Because you never know, based on the specific workloads, what technology is best, how it's going to perform, the cost differences, their vision, where they want to go, right? And trying to force Flink, or for example, a product in there just to churn, doesn't make sense for anyone. The thing is, for both parties to actually succeed together, create some meaningful success stories. Because if, for example, you trust me, or yourself as a consultant, and I just try to sell you stuff, first of all, I need credibility, and it's not meaningful for anyone. Eventually, you will churn. So,
Approaching the problem of analysis of performance of stream processing systems, I see kind of three dimensions of it that impact the performance in different aspects, right? So one is the volume, and this is, I guess, the traditional problem in analytics, right? Like, does your system scale to the volume that we don't have to worry about it? Is there horizontal scalability? And single node systems don't. They might be able to handle a lot of volume, but there always will be a ceiling at some point. Another dimension is the query complexity, because moving volume from A to B, it's not the same thing as joining 50 different tables and running very complex processing on it, right? So this is the second dimension, and this is where benchmarks like Nextmark were kind of invented to, although I've heard some criticism of it from one of the vendors. So the query complexity, how much logic do you actually need to run? And the third dimension is that I've heard this from the CEO of Feldera, that stream processing systems might not, and one of their unique selling proposition is that they are able to execute any SQL query, including recursive queries. So this is another dimension, that there might be a bottleneck if you are trying to do something that it might not be possible, and you might need to build some workarounds instead of like executing any SQL statement that comes to your mind that's like semantically valid.
Or just write code. I mean, yeah. I think it was recently that I saw a really complex query that was doing complex event processing. I was like, this will be way easier, at least for me, because I write code, right? I was like, this is going to be way easier for me just to write code. I needed so much time just to figure this thing out in SQL query. I'm like, okay, code, I prefer it. So
something talking about technology, what I see a lot is talking about technical capabilities, but something that I think would benefit from a lot of attention is the logical architecture, like how we model our data. And because if you get super complex inputs, then you have super complex problems and super complex queries, right? And very often the problem you have is the result of the fact that you haven't designed the data model properly, or haven't taken a step back to rethink the whole architecture, and you are just trying to apply solutions to the existing state of things, right? And very often this an incredible level of complexity is a consequence of some shortcuts that somebody took 3 years ago, if you know what I mean.
Yeah.
Anyway,
I think data layout is one of the major problem. Like, no matter how fast the engine could be, or how efficient it is, but if your data layout sucks, you would eventually have a high processing time, pay up lot of costs and things like that. So I think the basic predominantly the first step should be on the data layout segment as well.
I'm a huge fan of the approach of data mesh here. I've been reading a lot about and talking to a few people about how this was implemented, but it provides like enterprise level framework into decentralization and how to actually make your data products autonomous. So it is fascinating to me. I'm still yet to actually build something that does it, but the data modeling aspect is very often overlooked, and it's just easier to start working with what you have today. And but also we've talked about this before, this inertia and barrier of entry, like to actually make a deeper change. It's a risk and it's an effort. I'm trying to browse through what I set out to talk about in the beginning, but state storage, this is something that I definitely want to ask about, because there were some innovations in Flink 2.0, right? We have disaggregated state, and we have 4ST. Is this how you pronounce it? Or forced?
Actually, yeah. No idea how it's pronounced, but it's basically short for for streaming. So I typically go with 4ST So it's a bit.
So how does this work? This is a new thing in Flink, right? Before this, Flink had, as far as I understand it, it had RocksDB that was extremely widely used, but RocksDB is an database that is running in an instance storage of a worker. So this is limited to a single worker, right? This is not a distributed system. This is local storage on a worker and also in memory cache. Is this more or less correct understanding?
So basically, it can be it's a single instance on each task of a Flink job. So basically, if you're within a worker and you spin multiple Flink jobs, and these Flink jobs run on multiple tasks for each stateful computation, that task is going to have its own RocksDB instance.
Okay.
Now, the problem there, and basically, the problem there was that even though it's fast, it's not really built like RocksDB per se for cloud native environments, in the sense that there were local disk constraints. The larger the state grows, you might start observing like multiple issues with your checkpoints. And because it takes lots of time, basically it also used a single threaded model to do all the processing. Anyway, it had a few limitations, would say, that were not a good fit for cloud environments, including.
So not only the size bottleneck, the upper size limit, but also some limitations around resource consumption, right?
Consumption, yeah, memory constraints when it comes to containerized environments. There are a few different aspects. Now, in Flink 2.0, Flink 2.0 tries to address it in the sense that it tries to disaggregate the state, of course, and bring everything into object storage. It introduces lots of asynchronous APIs to get rid of the single-threaded model, and there are lots of benefits there in the sense that for cloud-native environments now, all the rescaling times, for example, all the recovery times, because state doesn't have to be downloaded on local nodes anymore. Everything is on remote storage. All the nodes have access there. Things basically get easier. And still for performance, although I don't know if it's merged, if I don't think the work is complete yet. This is something I'm also waiting for. It's going to introduce local caches for hotkeys locally, because you always have with the S3, you have the the network cost. And the other interesting part is going to introduce remote compaction. These are the main two features I'm waiting for to be completed in that aspect. And the other part is that hopefully now with this disaggregated state, we can also make, let's say, better APIs in terms of state inspection, like what Spark has, for example. Like I think it has capability to inspect state in terms of a data frame, just run a query. I think now this is really, it's going to be easier now with this disaggregated state to create all these things easier on Flink. There was some work in the past, but wasn't ideal.
You would probably basically like just flash the state to some external sync, right? If you wanted to check it live.
There were also some APIs for state inspection, but they were just a pain to work with. So,
yeah. So I think that I mean that from what I'm hearing from you, the state storage is not solved to a satisfactory level yet in the open source Flink. That what I'm hearing is that, and correct me if I'm wrong, but that this is a very significant innovation, but like there is still some work left to be done in this aspect. Is this?
So basically, it's more about. So currently, Flink is on the release 2.1. So basically, as it's natural with all, let's say, major releases, it's only natural to wait for a few patches before also going into production with that. These features don't mean necessarily that it's not complete. It's just some really nice
Okay.
enhancements that will further enhance the performance and the overall process of disaggregated state.
Yeah, cool. Yeah, and I've read a little bit also about how Rising Quest solves it. So I'll take this opportunity to because like I went through the like 7 different solutions to get a bit of a high level understanding to maybe build engagement for today's session. And there are a few problems there that are being solved. One is like fully S3 remote state with like local compute using either local disk or disk plus memory as state cache. The solutions differ in a way that there are solutions that support distributed cache and those that don't. Almost all of the solutions support S3 as the primary state storage. As far as I remember, I recall one that doesn't. So S3 is widely used, but also like the differentiated capability is that can you partition state across multiple workers, right? And this is what I see as yeah, like kind of the differentiator, or are you able to handle arbitrarily large state? I think the most I've read about this is coming from Rising Wave because they have it's called Hammock. It's part of the Rising Wave, but also it's a storage engine with 3 layers of cache that uses S3 as the source of truth, but also maybe like the durable state, but also local disk and in memory for like different levels of hotness of the data they have. I like the idea a lot. I haven't played around with it yet, but I guess that's this is in my mind the reference point, and then but if you need to like handle this distributed state, right, and very often for a lot of problems the state fitting either in memory or in memory plus disk of a single worker will be perfectly fine because it just wouldn't grow to this size.
Mm-hmm.
Yeah, we got into this a little bit earlier, but Sachin, maybe now that you are here, we've talked a lot on the data pools about Kafka and Iceberg. Giannis was well, we were talking about Flux and Paimon that tries to address this in a pretty unique way. But yeah, maybe Sachin, the question, because I think we are running until the end. So maybe a question on we saw a lot of Iceberg adoption in the space, but also like table topic duality and or stream table or table topic feature, however you call it, table flow like solutions. We see this a lot in the Kafka vendors. Do you like have you seen this used? Because where I'm getting with this is that we have the capabilities, yeah, and how and what we were talking about is Paimon and Flux that kind of propose an integrated solution to a single problem. We've talked about with Giannis before the stream as well. Want to share your take on kind of the value of it, or maybe and how this is used?
Yeah. So, couple of things. So for me, finding the impact downstream is pretty important. So until unless you have like a data cataloging solution where you have this topic and the downstream data sources properly sharing their lineage, that until you have that, that's fine. You will have complete lineage end to end. Otherwise, what you would end up is maybe if you're using some streaming solution such as Confluent and you are using Databricks downstream, they will have their own governance setup. They will have their own impact assessment setup, and then there is no tying of both of these concepts there. That's one part. So I really like this table topic duality in that way, and I think Confluent has recently, I'm not sure when they will launch, but they have recently launched the where using Tableflow you could uh, you could have the stitching available where you could see the end-to-end lineage of this topic is actually materializing to this Delta Lake table or something like that. So working collaboratively with Databricks on that side. That's one part. The other part is on the storage and compute segregation step, right? So and that is other than the egress cost that we have with Kafka. This is the another dominant factor which will rise the compute cost as well, because you would need to store a huge amount of data, maybe for like your CDCs or event streaming, event sourcing or stuff like that. So and this provides you opportunity to store it on a cheaper storage. Uh, S3, and I think Ivan has recently launched Iceberg Topics. Uh, Pretty interesting take there as well. But yeah, so these are two areas where I see their applications for me. But I would love to hear what you guys think where it's more useful.
Yeah, I mean, I was from the very beginning. I was a big fan of like this Kafka Iceberg pairing, and we've talked about this on Data Pools a lot. I've yet to publish my take on the recent release of Avon, but I like this a lot as well. And the huge advantage of this is that Kafka is the protocol for data streaming right now. And this is the established standard that's extremely widely adopted, and Iceberg as well. And whether you have a single layer that kind of merges these two, or you have like capability built into Kafka, however you achieve this and whatever trade-offs you have, it's great to have it. And this is a fantastic improvement over manual ETL pipelines. But Giannis, kind of looping back to what we discussed, I think a week ago, or a bit less on this topic. I see a lot of value in an integrated solution. I think that an integrated solution that has comparable capabilities, it will have more of them. It will be of better quality and will have better integrity between the systems. It will be just easier to deliver high quality, right? And with I think 5 or 6 different vendors providing the integration between Kafka and Iceberg, I'm pretty sure that at least one of them has a bug in there, that there will be no bulletproofness in the whole landscape, right? So having an integrated solution, it just has different level of I think quality, and both on the side of no bugs, but also on the side of features delivered, right? It's just easier to maintain and build than to manage an integration between two evolving interfaces, even if they are not evolving every week. But we've had Iceberg v3 release, I think, a month ago or so. So yeah, I'm a big fan of Kafka plus Iceberg, but then an integrated solution will always be better. However, there is the barrier to adoption. That's my take on it. Giannis, care to share your opinion on this?
So I have lots of opinions on that, but what I'm basically looking to see in production use is how the different approaches from these vendors compare. Because, as you said, some choose to add directly into the tier into Kafka's tier storage. Some use some external services like Flink and create an external service. For me right now, it feels like the Flink approach is better from different perspectives, whether it's about scaling independently, whether it's about the Flink Iceberg connector is quite sophisticated, whether it's about... Anyway, I think it has some benefits, but I'm eager to see how this plays out. And you have also the other solutions, like I think Red Panda has the Red Panda topics, which I think allows you both to tier the data and also tier it as iceberg tables, basically create two copies. But I think it's also the tier storage. Do you know about that? I'm not sure. And there is also the AutoMQ approach, which also feels, I think I haven't looked much into it, but it also feels from a high level, it seemed really interesting, and I'm really curious to understand it better. And I think they will also be publishing some success stories from their customers. Basically, this is what I'm looking forward to better understand, to see the actual value these customers see, how these solutions actually scale, because at this point, it's just a solution that someone markets. I'm waiting to see the customer testimonials.
Yeah, technical capabilities that are really cool to discuss about, but seeing the money behind it, and especially big money, because big money means proper due diligence, and then painful effects if things go wrong. I love this big customer stories, and I read them passionately. What I really like about this that's been released recently, the Kafka plugin from Ivan and Buffstream as well, is being able to serve data from Iceberg over the Kafka protocol. This is really cool. Yeah. Anyway, guys, we've been going on for an hour and a half, so I will move on to the closing screen now, and we haven't mentioned this yet, I think, but this is the last episode of this season of Data Pulse. So we'll take a break for some time before we come back. So I'll take this opportunity to thank you, Sachin, for doing this with me over the past few months. It was a fantastic journey. And thank you very much, Giannis, for coming with us today and sharing what you have shared and talking and discussing, and in general your spirit and everything. I'll also thank the other guest that we have two months ago, Alex Merced. Thanks a lot, man. It was really cool to host you here as well. And
congratulations on your book, Alex. We need to congratulate him for his new book.
Yeah.
Cool.
I think he's written 5 books now. I'm not sure, and all of them are bestsellers.
Really?
Yeah, so we will not be talking about the next episode yet. We need to take some time off and reflect on what's coming. All of the recordings are available on YouTube, LinkedIn probably as well, but YouTube is a way better library. So this is you can see the link, take a photo, and rewrite it into the browser if you want. Yeah, so. This is the end, I guess. Thank you, guys. It was nice, really nice talking to you. Great, Sachin, that you've called in after some time.
Yep. And thank you so much, Giannis, for joining us. We are very fortunate to have you. Sorry, I missed this initial part, but it was really fulfilling to learn this. And maybe once we are back, we would love to have you again, maybe for a much longer session. So yeah, but really
Yes,
had a lot of fun.
Thank you for having me, guys. And again, big kudos for this great initiative. This is something that was really needed to actually also evaluate all the solutions in a nice way. Okay, cool. So it was nice. It was fun. Talk to you again.
Yeah. See you all. Bye bye.